all for my today IoT class. So myself Dr.V.Karuppuchamy, working as an assistant professor in the Department of Computer Science Engineering, PSNI College of Engineering and Technology. So first let us know what do you mean by Internet of Things. So from this word Internet of Things, we can easily understood the meaning of an IoT. So we are providing the Internet services to the living object as well as non-living object. Why we need to provide the Internet services? Means monitoring and controlling and exchanging the data in between the objects and the Internet. So this is a small pictorial representation about the Internet of Things. So any device we can deploy this technology. Anybody we can use it. Either it may be educated people or non-educated people. So anywhere it may be a surface, it may be a hill station, we can use this technology. In any business, not only the particular business, in all the business, this technology has been entered, such as education, then transport, government, then airways. So in all the fields, this technology has been entered. Then any network we can use it, either it may be 3G or 4G or 5G. So based upon that network speed, this technology will be work in a good way. Then any time we can apply this technology. So this is a small pictorial representation I have been used to understand the Internet of Things. So in this picture I have been used living object and non-living object. So both the objects we can apply this technology and we can monitoring and we can controlling and exchanging the data. So what are all the connectivity protocols we have used in this IoT? Then first one is the internet, then second one is the satellite, then Wi-Fi communication, then radio frequency, then RFID communication, then Bluetooth short range communication, then NFC near field communication. Suppose if the distance is not limited, we can apply this connectivity protocol internet. So from here we can easily control the any objects, it may be a living or non-living object at any place at anywhere. Satellite communications also, the distance is not limited. So from India to the some other countries like US, UK, in that place we can control the device from here. Then for short range communication we can use Wi-Fi. Then radio frequency also, the radio frequency is always sensing that particular object is present or not. So this radio frequency is used to send the signal from one place to the another place. Then RFID communication. So this RFID communication has been deployed into the toll gate. So this RFID always scanning that particular barcode. If the barcode is present, it will be scanned about that particular details and sent into the cloud. Then for short range communication, we can use Bluetooth, then NFC also. So this is architecture of the IoT. So in this IoT, we have three types of architecture. Then 3-layer architecture, 4-layer and 5-layer architecture. So the first in 3-layer architecture, the first layer is the perception layer, then second one is the network layer, then third one is the application layer. In 4-layer architecture, in between the network layer and perception layer, we have used support layer. Then in 5-layer IoT architecture, the first layer is the perception layer, then second one is the transport layer, then processing layer, application layer, and business layer. Next, let us know what are the devices we have been used in this particular layer. The first one is the device and sensing layer. So what are the device we are going to deploy? Either it may be video camera or RFID or barcode reader or some other communication device. Okay, that these are all the device comes under the device sensing layer. Then in network layer we are using the Bluetooth and Wi-Fi, then Zigbee, then LoRa, NFC. So these are all the communication protocol. So based upon the distance, we can use this connectivity protocol. The next layer is the middleware layer. This is the important layer of IoT. So that the data analytics can be done here. Then decision also taken here. Then database, all the data will be stored in this cloud. So what are all the things scanned by this device or sensor? All the data will be stored in this cloud. Then service and application layer, we can provide the services. So then the next layer is the application layer. The smart cities, then smart transport, then smart health, then smart energy, smart living, then smart industry. So wherever the smart is there, the IoT should be there. So what are all the layers and what are all the protocols we have used in this IoT? In link layer we are using 802.3 for Ethernet, 802.11 for Wi-Fi, then 802.16 for WiMAX, then 802.15.4 for WPerWAN, then 2G or 3G or 4G. So these are all the things will be comes under this link layer. So in network layer, by default we are using is two protocol. Then first one is the IPv4 protocol, then IPv6 protocol, then low power personal area network protocol. So in IPv4 protocol is a 32-bit address. In right now we are using to develop the IoT technology. So in IPv6 not been developed in India. In some other countries they are using this IPv6 technology for high speed communication. So 6 low power band personal area network we can use this IoT. Then transport layer, by default we are using this two protocol, TCP protocol and UDP protocol for wireless transmission and the data from one place to the another place if the distance is not limited. For we can use the TCP protocol. Then UDP protocol is a wireless protocol. Then application layer. As in application layer, what are the protocols we have been used? HTTP protocol, hypertext transfer protocol, then COAP protocol, then WebSocket, then MQTT protocol. So this is one of the important protocol in IoT. Message queue telemetry transport. Then SAM protocol, then DDS protocol, then AMQP protocol. So next, let us know the picture of the IoT devices. What are all the boards we have been used to develop the IoT technology? So the name of the board is Raspberry Pi. It is like a mini computer. It is a lightweight. So we have separate OS for this board. The name of the OS is Raspberry OS. We can install the Raspberry OS into this board, and this board will be act as a mini computers. So we can connect all the type of sensor with this board. So this is the gas sensor. So this is ultrasonic sensor. So this is the IR sensor. This is the touch sensor. Then RFID sensor. So a number of sensor will be connected with this board for data analytics. So where we can buy this board? Okay. So in all the websites like Amazon, Flipkart, then Snapdeal, all the boards are available. Arduino board, then Raspberry Pi, then Node MCU. These are all the basic IoT boards will be available in the online market. The next one is what are all the device will be used to develop an IoT projects. So this is the Arduino board. So what are all the other devices or what are all other hardwares will be used to connect the IoT. So till now the 37 sensor is available in the market. So these are all the different types of sensor: gas sensor, pressure sensor, then object detection sensor, temperature sensor, then voice detection sensor. Okay, a number of sensors available in that market. So we can purchase it and we can develop our own application. So these are all the simple example of that sensor, touch sensor. So when you touch this sensor, immediately the signal will be sent to that IoT board. The board may be an Raspberry Pi or Node MCU or Raspberry Pi Pico. So this is ultrasonic sensor. We can easily measure the distance between the two objects. Okay, for that purpose we can use this sensor, and also this sensor is used to detect that particular object is there or not. Then PIR sensor, also then speed sensor. We can by using this sensor we can measure the speed. Then temperature sensor, we can measure the room temperature, particular places of the room temperature here. So this is the pictorial representation of the temperature sensor. So in old temperature sensor they are using 4 pins VCC and out, then NC and ground. So VCC it is an voltage, so it is out pin, there is NC pin, so this is the ground pin. But right now we are using a digital sensor. So in digital sensor we are using only the 3 pins, the 1 pin for voltage input, then another 1 pin for ground, then middle pin for data out. So this is an IR sensor. In IR sensor we have 4 pins. The first pin is connected to the VC, then second pin is connected to the ground, then third pin is the digital output, then fourth pin is the analog output. So in temperature sensor we have only the 3 pins because the output will be a digital format only, numerical format. So in IR sensor we can get the output also as the analog format. So this is the these are the types of sensor available in the market: temperature sensor, vibration sensor, magnetic sensor, then key switch module, then infrared emission sensor, then small passive buzzer, then 3 color full color LED assembly module, then temperature sensor, then read module, then flame sensor, and etc. So next let us understand about the DC motor. So this is a small motor. The input voltage of the DC motor is 3 volt. So we can give maximum up to the 6 volt. So for continuous rotation we can use this motor. The lead is connected directly. The lead is connected to the battery. So based upon that battery pole, it will rotate. If the battery is connected directly to this wire, positive and negative, it will be run in forward direction. If suppose if the pole is connected in a reverse side, the motor will run in a backward direction. So this is the small code to run a DC motor by using an Arduino. So how we can write the code to run this motor in an Arduino? So int motor pin. Okay, so initially the motor value will be an integer. So we are using the data type as integer. So motor pin is the variable. So I am going to activate the third pin. Okay, so I am going to activate the third pin is directly connected to the motor. So in this board totally 14 pins are there. So what are all the pins you are going to activate? So you need to write the code. So again here I have activated the third pin. The third pin is connected to the motor. Then while setup. So which line you are going to execute again and again. So that thing should be written in this while loop. So what are all the variables you are going to use? That things you should be declared in that while setup. So this is a small programming to run a DC motor. So here I am using integer because the input value is an integer motor pin equal to 9. So I am going to activate the 9th pin. So while setup, so in while setup I am going to activate the motor pin. So pin mode, motor pin, so 9th pin, then output. So the 9th pin will be an output to the motor. Then we have to begin that serial communication, serial dot begin. Then 9600 is the baud rate to execute that particular serial port. Then while the serial is not present, the speed to the 0 to 255. So what are the lines should be executed and again, that should be given inside that while loop statement. So if serial dot available, if the motor is available, if the motor is directly connected to that board, integer speed equal to serial dot pass it. It will be connected into the integer. The motor will be run 0 to 255 times. First run, then second run, then third run. So based upon that loop, it will be executed 0 to 255 times. The next important motor is servo motor. So this is one of the important thing in Internet of Things, because so based upon that signal, the motor will work in forward direction as well as reverse direction. So in this motor we have 3 pins. One pin for ground, then another pin for voltage input, then another pin for signal. So based upon that signal, the motor will run forward direction as well as reverse direction. The angle of this motor is 90 degree and 180 degree. So this is a small code how to run that servo motor. So initially we have to include the packages has include servo.h, then servo, then my servo is a variable. So int pin number is 0. I am going to connect this servo motor to the 0th pin, so integer value. Then while setup, so 9th pin I am going to activate. Then while loop, so while value this value equal to map, then value 0, 1023, then 0, then 180. So this is the angle. So based upon that angle, the motor will run. So these are the different types of the servo motor. In AC servo motor and DC servo motor. In AC servo motor, positional rotation and servo motor, then continuous rotation servo motor, then linear servo motor. So in DC servo motor, series motor, then split series motor, then shunt control motor, then permanent magnet shunt motor. So these servo motors will be used into making a robot. The next important thing is stepper motor. The stepper motor is a step motor. It is a brushless motor. It is a synchronous which divides a full rotation into a number of steps. So based upon that steps, we can easily run this stepper motor. So for that we need to write a code by using that steps per revolution of 12, 24, 72, 144 and 180 and 200 also. So this stepper motor can be controlled with or without feedback. So where we can apply this stepper motor. So if you are connecting that one motor to the some drones or aeroplane technology, so without changing that DC volt, the motor can be the motor rotation can be easily increased and decreased without stop. So this is a stepper motor. It will be used in all the airplanes. So how we can run this stepper motor? So this is the bearing house. This is the outer motor case. This is the stator coil. So this is the stator poles. So these are the magnetic shaft. The magnetic shaft will be run inside this stator. So automatically the shaft will run. So the which device is connected to this motor, it will be run automatically. How we can run the stepper motor? By using this code. So you see, first we can first we can include these packages as include stepper.h. You can initialize the pin. Stepper evaluation per evaluation is 90 degree. Then void setup. Then my step speed is 5. Then which line should be executed again and again, that should be given inside the while loop statement. So here the serial.print, then clockwise we are going to run the motor in a clockwise direction. Then my step revolution. Then delay will be on 500 milliseconds. So this value will be this value is milliseconds, right? So serial.println and counterclockwise. Then my stepper speed is automatically it will be rotating clockwise direction. The next one is the relay. It is that the relay is electronically operated switch that is remotely activated by an electromagnet which pulse a set of contact to either make or break a circuit. So the signal will be sent to this relay either zeros or ones. The 0 means off, 1 means on. So this is the pictorial representation of the relay. So in relay we have used in 3 pins. Then 1 pin for VCC directly connected to the voltage. Then another pin for ground. Then another pin for data pin. So this data pin is directly connected to the Arduino board. So the signal is received from the Arduino board. If the Arduino board sends 0, the relay will off. If the Arduino board sends 1, the relay will on. So this is the software we are used to develop the IoT technology, Arduino IDE. It is a open source software. It is a lightweight. We can easily download the Arduino IDE from the website. So different types of IoT boards is available in the market. So it is an open, already said it is an open source. It is a microcontroller based boards. Microcontroller based boards. Both 14 input output pins are then available in that Arduino board. So we can easily use it. The board has 14 digital input output pins already I said. The 6 pin capable of pulse width modulation. Then 6 pin analog pins input output pins. Then the ID integrated development environment can be used to activate these pins. So this Arduino board will be support up to the 9 volt to the 12 volt. So this is a creative common attributes. It is an open source license. Suppose if we want to contribute to develop this Arduino IDE, we can. So this is a small pictorial representation of the Arduino UNO. So this is a digital serial output pin, serial port. So this is circuit serial programming, ATMEL microcontroller. So this is the microcontroller. Suppose we are writing a code and send to this code, then our code will be stored in this microcontroller. So this analog output, analog device can be connected to this pin. So this is a power supply module. So we can give the power supply to this code to run our program. So this is the power input. So this is the socket directly connected to the CPU or directly connected to the adapter. So this is USB port. We can connect this microcontroller board to our computer also. So this is a pin configuration of the following boards: Arduino UNO, then Arduino Mega, then Arduino Nano, Arduino Leonard, Arduino Duo, then LilyPad Arduino, Arduino Micro, then Arduino Pro Mini. So this is the pictorial representation of the Arduino UNO R3. So here the n number of pins are there. So this is the digital pin, digital D0, D1, D2, D3, D4 are the digital pin. So PWM means that pulse width modulation. So this pin is used to connect the analog device. The most of the standard board is available and probably the best choice for a beginner to use this board. Directly connected to the USB cable, and we can easily send a simple code to this board. For a simple kind of IoT application, we can use this board. So V pin is connected as the input voltage. Then 5 volt probably we can give this board. The minimum voltage is 3.3. The ground pin is there. then reset pin is there, then analog pin is there. Suppose if we want to erase our program, we can press the reset button, the existing program will be erased, we can send the new coding to this board. So digital pin, totally 14 digital pins are there. The digital pin starts from 0 to 30. So the first pin is the RX pin, then second pin is the TX pin. This pin will be used to connect the communication device like Bluetooth and Wi-Fi. So the rest of the pin we can use to connect our rest of the pin we can use to connect our external devices. SS pin number 10 used as a slave select. MOSI pin number is 11. Master out slave in. M stands for master, O stands for out, S stands for slave, N stands for in. Then master input, slave output. Then SDK pin number is 13 used to do serial clock. Then LED pin, the default LED is there. Suppose if we need, we can use this LED. Then reference pin will be used to calculate the analog voltage. The next board is Arduino Mega R3. So here the totally A0 to A15, 14 analog pin is there. Then here digital pin 22. The starting value is D22, D24, 26. So totally 16 pins is there. So we can use this digital pin. Here the n number of analog pins are there, n number of digital pins are there for a middle kind of application. Suppose we are going to connect the 5 or 6 sensors or 5 or 6 relays, we can use this board. So the main advantages of this board is the advanced user. So those who have good knowledge in IoT, they should buy this board and do a smaller kind of applications. Then voltage pin. This is the input voltage pin. Then 5 volt is connected as a power supply. The minimum voltage is 3.3. The ground pin is connected to the ground. Then reset pin is there. We can easily erase our code by using this button. Here also already said 14 analog pin is there. We can connect the 14 analog devices with this board, and also serial port is there. Then external interrupt pin is Arduino is used to produce the external interrupt, and it is done by the pin number 03, 21 and 20, 19 and 18. So in this board I2C pins are there. So in all the Arduino boards I2C pins are there. So the main purpose of using I2C pin is we can convert the 16 pin into the 4 pin. Okay, so that is the main purpose of using I2C converter, integrated converter. Then serial peripheral pins are there. We can connect the serial devices. Then master input, slave output pins are there. Then LED pin, then clock pin, then reference pins in this board also. The next board is Arduino Nano. So this is a small board. It is a very lightweight board for simple kind of application. Suppose we are going to make a digital watch. Suppose we are going to make a very digital light. Okay, for that kind of applications we can use this Arduino Nano. So by the memory of this Arduino Nano is very less than 4 KB of the program can be installed in this Arduino Nano. Very less number of sensors is connected to this Arduino. The size is 2 times lower than the normal board. So the Arduino Nano is the more breadboard friendly. So in this board we have an voltage pin, then 5 volt, then input supply, then 3.3 voltage pin can be used to connect the external relays and sensors also. The ground pin is there, then reset pin is there, then analog pins are there. So in this board we have only the 7 analog pins, 0 to A7. So in digital pin D0 to D13 almost 14 digital output pins are there. Then serial pins, then external interrupt pins, then pulse width modulation pins. So what are all the configuration, what are all the supports done by this normal Arduino UNO, then same thing will be support this Arduino Nano also. The only the difference is it is a very lightweight and also the size is 2 times smaller than the normal board. Serial pins are there, then master output, slave input pins are there, then master input, slave output, then clock pins are there, then I2C pins of the board is used to connect the I2C communication. Then pin 4 signifies the serial data line. SDA stands for serial data line and it is used to for holding the data. Then pin number A5 signifies the serial clock line, and it is used for offering the data synchronization among the device. Then LED pins are there. Then reference pin used to know the reference voltage of that particular board. The next board is Arduino Leonard board. So it is some good board compared to the other boards. So the board is lightweight, and also we can connect the number of devices. Arduino Leonard board. So those who have good knowledge in that IoT, we can use this technology. So what all the pins are there in that previous boards, the same pins are also there. Here the number of pins, the number of analog pins and the number of digital pin is high. So pin number, LED pins are there, and then reference pin voltage are there. So next board is Arduino Duo. So this is the pictorial representation of the Arduino Duo. This is I2C conversion port, I2C communication port. So this is the voltage for ADC. Then this is the ground port. Then pulse width modulation output. Then 32-bit ARM microcontroller. Then this is the erase button. See, when you press this button long, okay, maybe 2 seconds or 3 seconds continuously, the program will be erased. So this is serial communication port, will be connected to the serial device. Digital input output pin, we can use it. Serial peripheral interface communication also there. Then analog inputs are there. Then power pins. Then power for standard alone RX and TX pins are there. Receiver transmission and receiver and transmission, and it will be connected to the Bluetooth and some other Wi-Fi devices. Then programming USB devices, USB port is there. By using this port, we can send our programming to this port. So the main purpose of this Arduino Duo is, then previous boards we can use only for the deploying a smaller kind of IoT projects. The main purpose of using this Arduino Duo is to create a CNC or 3D printer. So by using this board, we can easily create a CNC and a 3D printer. So in this board, we have voltage pins are there. Then 5 voltage is the input supply. For external resource, we can use 3.3 voltage. Then reference pins are there to monitor the voltage of this board. Then ground pins are there. Then reset pins also used in this board, okay, to reset our program. Analog pin A0 to A11 pins are used in analog input, and is the range of 0 to 5 voltage. In all the boards, the analog voltage is 0 to maximum 5, right? So then pulse width modulation pins are there. Then I2C communication is used to connect that SDA and SCL line. So SDA stands for serial data line, SCL stands for serial clock line. Already I said the main purpose of using the I2C is the converting the 16 pin into the 4 pin. Then erase buttons is there. When you press this button long time, automatically the current program will be erased. The next board is the LilyPad Arduino. So it is like a small watch. If you are creating a digital watch, we can use this LilyPad Arduino board. It is like an Arduino Nano. The size of the board is like a small circle, right? So in this board, we are using that LilyPad based on that circular PCB with the wide holes, and the controller and the optimized for the e-textile and wearable projects. Suppose we are going to make a wearable devices like smartwatch or heart monitoring sensor or pressure sensor or temperature sensor. So better we can use this LilyPad board. So in this board we also have an VCC for an input. Then ground pins are there, reset, analog pin, digital pin, then serial pins are there. So in pulse width modulations, the pin number is 9, 10, 15, 16 and 17. So each and every board, the input pin, digital pin and pulse width modulation pin number is different. So master input slave output, master input slave output, then SEK, then I2C communication. All the pins are available in this board also. The next board is an Arduino Micro. So it is a very small size board. So this button is called as the reset button. Then master input slave output, then clock, TX transmission line, receiver line, RX LED, then TX LED. When the signal is received, this LED will blink. When the signal is sent, this LED will blink. Then ground, serial data, then serial clock. Then all the pins are available in that Arduino Micro also. So Arduino Micro is the smallest board in the Arduino community. The Arduino Micro has the more number of analog input pins in Arduino UNO. So in this board we also have V in, voltage in, then 5 voltage the maximum input supply. For 3.3 voltage is used to connect an external devices. In this board is also has an inbuilt regulator, then ground pin is there, reset pin is there, analog pin is there, then digital pin. The digital pin number is 4, 6, 8, 9, 10 and 12. Then analog pin is A0 to A11. External interrupt pin is there, then pulse width modulation pins also there. Then serial pin is used to connect the SDA SCL line, then I2C pin is also, then LED, then reference pins also there. The next board is Arduino Pro Mini board. From this word mini, okay, we can easily understand the size of the board is small. So in this board we have only TX and RX pin to connect an external Bluetooth devices, voltage in, then ground. We can connect one more Bluetooth devices also by using this pin number. Then reset pin is there, ground pin is there. So this is the microcontroller pin. This is analog pin A0, A1, A2, A3 are the analog pin. Totally 4 analog pins are there. So these are the digital pin like 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12 are the digital pins are there. So in reset pin, buttons are there. When you click the reset button on, it will be the program will be erased automatically. So the main advantages of this board is the input voltage is 12 volt. Then there is no need any regulator to give the input source. So voltage input pins are there, then voltage ground, then ground button, then reset button, and analog pin, then digital pin. External interrupt pin is also there, then analog communication. The pulse width modulation pin number is 3, 5, 6, 9, 10 and 12 are used to connect the PWM pins. Then rest of the pins are common to see the previous codes. So these are all the overall understanding about that Arduino board. These are all the boards available in our market. So how we can code this board? So this is the most important thing. So this is the open source software. We can download it from the Arduino.CSE community to write our code. So this is an environment, IDE environment. So here we are going to write our own program. So in all the initialization should be done in void setup, inside the void setup. So what are the lines should be executed again and again, that should be given inside the while loop statement. So this button should be called as a compile button. So this button will be called as the send button. See, when you click this button, automatically your code will be stored in this board. Right? When you click this second button, automatically your code will be stored in this board. So based upon your code, the board will work. So this is the save button. Right? This save button, this is the upload button, sketch options are there, tool options are there, edit options are there, then file options also available in this environment. So this is the current status of the IoT. This is the world population count. This is the connected device per person. So in 2003, see the connected device is 500 million, then world population is 6.3 billion. So in 2010, connected devices 12.5 billion, then world population is 6.8. So in 2015, 25 billions and 7.2 billions. So in 2020, connected devices 6.58, then connected devices 50 billion, then world population is 7.6. So changes is the only thing permanent in this world. So this tag will be very suitable for this technology. Let us move to the next slide. So in 2030, IoT connected devices greater than the world population. So this survey from the industry. So where we can use to this IoT technology. So in smart homes we are using the 100% IoT technology. So right now we are using smart bulb, then smart speaker, smart TV, smart light, smart grinder, everything. It will be smart. Wherever the word is smart, there the IoT technologies are there. Then wearable device, all the wearable device we are using, and 60% of the IoT technology used in this wearable technology. Then 34% of the IoT technology used in smart cities, then 28% smart grid, then 25% industrial internet, then 19% connected cars, then 6% connected health, then 2% smart retail, then 2% smart supply chain, then 1% smart farming. So till now we need to improve in smart farming to use this technology. So which companies are used in this technology, or what are the topmost companies are used in IoT? The first one is IBM. They are developing IoT products. Then Google, then Intel, Microsoft and Cisco. These are all the top level IoT companies focusing on IoT projects. So these are all the applications of the IoT. Smartphones comes under IoT, smart home, personal computers, then analytics, in-flight services, then online shopping, music, home lighting. Already said where the word is smart, there the IoT technologies are there. In smart grid, see in all the smart grid places we are using an IoT, thermal power plant, then hydraulic power generation, then photovoltaic, then renewable energy, then wind generator, then ecological vehicle, then cities, homes, etc. and etc. Then smart farming. So we need to deploy this technology more in smart farming, because so till now we are using only 1% of this technology in that farming. So smart tractor, smart lights, then smart control, smartphone control, then everything will be controlled by our phone based on the cloud. The next one is the smart health, telemedicine, then digital health, then telehealth. So from this place we can easily connect it to the other cities or other countries doctor by using this technology. So smart industry. So by using that technology, even a single person can control all the robots. The technological challenges of the IoT, it could not be processed the large volume of data, even though we can say the smart. So till now the technology cannot be processed the large volume of data. Then power supply failure. If the power supply is not there, there is no IoT technology. Need high speed network. If the network is slow, definitely the IoT technology will not work. And also security. This IoT technology has a very less security. We need to focus more on security part also. So this is smart city, smart manufacturing, where we can apply this IoT technology. By using this picture we can easily understand, right? Smart manufacturing, smart government, then mobility, then smart digital citizens, then open data, then smart health, smart farming, agriculture, then smart building, then smart grid. In all the places we can deploy this technology. This is the project number 1, Arduino blinking LED. So what are all the components required to create a simple IoT projects? The first one is the breadboard, then second one is the Arduino Uno. We can choose any type of board, right? So for creating this simple projects, right? Then LED, then 330 ohms resistor, then 2 jumper wires. So this is the connection diagram of making an LED blink. This is the Arduino board, breadboard. It is connected Arduino LED. Positive line is connected to this Arduino, then negative line, ground line is connected to this ground, and we can write the code. I will show the code, right? We can write the code and send to this board. Then based on that R code, the LED will blink, right? So this is the IDE environment, right? So first we need to click new button, right? Need to click new button. This line will be appear. We need to activate the pin number 8. So how we can activate the pin number? Pin mode bracket 8 comma output. Output will be on high, right? Then while loop. Then digital write 8 pin will be on. High means on. Then delay 1 second. After on, the delay will be 1 second. Then digital write 8th pin will be low, right? So 8th pin high, delay 1 second, 8th pin low. Again 8th pin high, delay 1 second, 8th pin low. Then again delay 5 seconds, right? So these are all the looping statement to blink an LED continuously. So based upon that 1 millisecond, the LED will blink continuously. So this is a smart blinking IoT projects. So based upon that code, the LED will blink. The next project number 2, obstacle avoidance robots. So in this robot we are using object detection, obstacle detection sensor. Sensor already we saw in our previous slides. So next project number 3, picking and placing a robotic arm. So this robot will pick that particular object and place into the some other place.